So next we need to look at the steps you go through to sketch the graph of a rational function. There are actually, I think, 7 steps that are listed in your textbook. I've kind of condensed that a little bit. What I would be looking for on a problem that I was grading, first thing I would look for, and this is kind of what I would recommend that you do, find the y-intercept. It's a good idea to know where the graph crosses the y-axis. So you're going to evaluate f of 0. Plug a 0 into the entire function and simplify. That's the y-intercept. Then the next thing you're going to do is find the x-intercept, or intercepts. There may be more than one. To find the x-intercepts, take the top of your fraction, set it equal to 0, and solve for x. That's going to tell you where the graph is going to cross the y-axis. The next thing I look for are vertical asymptotes. To find the vertical asymptotes, set the bottom of your function equal to 0, and then you want to be sure that whatever values you get for x, they do not also make the top equal to 0. Vertical asymptotes are next. Horizontal asymptotes. Okay, to find horizontal asymptotes, you're going to use the rule that I mentioned in the earlier video. Okay, and I don't have a good way of talking about that rule. So one option is that the power on the numerator, the top, is greater than the power on the bottom. If that's the case, there's no horizontal asymptote. If the top power is less than the bottom power, there is a horizontal asymptote at y equals 0. And if the powers are equal, then you look at the lead coefficients to come up with your horizontal asymptote. And then the next thing that you're going to do, I believe your textbook is also going to ask you to think about symmetry. Certainly remember that functions that have symmetry in the y-axis are even functions. Go back and look at your notes about what that means. Functions with symmetry in the origin, which is symmetry in the point, are odd functions. And you go back and look up what that means. The other thing that I want you to do is plot some points. Okay, you're going to just have to, when you find the y-intercept, the x-intercept, the vertical asymptotes, the horizontal asymptotes, that's a lot of information, but it's not enough to get a good idea what the curve is doing. You've got to plot some additional points. So you want to plot at least one, maybe more, between your x-intercepts and your vertical asymptotes, and at least one beyond. So outside of where, out further to the right and further to the left. So make sure you're plotting some points between x-intercepts and vertical asymptotes, and make sure you're plotting some points out to the right and the left. So the best thing that I know to do here is just, let's jump in with an example. And I'm going to need a grid, so hang on a minute. That'll work. Okay. So let's start with f of x equals the 2x squared over x squared minus 9. Now I'm going to immediately factor that denominator because that's going to make what I need to do a little bit later just a little easier. So step 1, I'm going to plug 0 into that function. If you plug in 0, you're going to end up with 0. So the y-intercept is 0. Step 2, I need to know what the x-intercept is. Set the top of your function equal to 0. Solve for x. So there's the x-intercept. Looking for vertical asymptotes, we're going to set x minus 3 equal to 0. and x plus 3 equal to 0, because those are the two factors that make up the denominator. So x equals positive 3 and x equals negative 3 are where the vertical asymptotes are going to occur. And then horizontal asymptotes. Okay, looking back at the original form of the equation, the powers on the top and the bottom are the same. So y is equal to 2 over 1. Looking at lead coefficients, y equals 2. Okay, so those earlier ones are vertical asymptotes. That's our horizontal asymptote. So next we want to start with plotting the information we have. We have a point 0, 0 that we know is on our graph because that's the y-intercept and the x-intercept. We want to sketch x equals negative 3 and x equals positive 3 and y equals 2 as our asymptotes. And you can see that that's not enough to know what this curve looks like. So I need to evaluate this function at some other values of x in between negative 3 and positive 3. What I would recommend is, do this the easy way. Grab your calculator. Oh, there we go. Grab the calculator. I have already entered this function in y1, and then now all I can do to make this easy is I can go back to the home screen and evaluate using correct function notation y1 of, okay, now let's think about this. Move that just a little bit. I'd like to know what's going on at negative 1 and negative 2 and at x equal positive 1 and positive 2. So negative 1 so what I just found is that f of negative 1 is negative 1/4 and f of negative 2 is negative 8/5, okay, which is, let's see, 8 divided by 5, 1.6. It's probably helpful to look at that in decimal form to know where that point should be. If we find y1 of positive 2, we've got the same y value. So f of 2 is equal to negative 1.6. F of 1 is negative 1/4. So let me plot those points. When x is negative 1, y is negative 1/4. That's about right there. When x is negative 2, y is negative 1.6. So that'd be about right there. Same thing on the positive 1 and positive 2. And now I've got enough information. If I use the asymptotes, knowing that our curve has to come closer and closer and closer and never cross those vertical asymptotes, then I can sketch this part of the curve. Now, to know what else is going on, I need to find some values of x that are bigger than 3 and some values of x that are less than 3. So I'm going to look at evaluating f of 3, less than negative 3, I mean. I probably will evaluate f of 4, and then I'll do the same thing for f of negative 3 and f of negative 4 and see what we get. So second enter pops that entry line back in. I can change the 1 to a 3. Oh, 3 is a dumb, that was not smart. Of course I get an error message there, because when you plug in 3, that's a 0 of the denominator. So we need f of 4 and maybe f of 5. and negative 5. Okay. Trying again. Get the cursor in the right place. 4 is 32/7. That's not very helpful. I'll figure out what that is in a minute when I'm done with the calculator. F of 5 is 25/8. And if we change that to insert a minus sign in front of that 5, I get the same thing, 25/8. And evaluating negative 4, I bet I get 32/7, and I do. Okay, so 32/7 is we'll call that 4.6. And 25 divided by 8 is 3.1. So back to my graph. When I plug in 4, I get 4.6. Yep. So that would be about right there. If I plug in 5, I get 3.1. So that's about right there. And that's enough really for me to get a decent idea using the asymptotes again. The curve's got to go through those 2 points and come down and get closer and closer and closer to that horizontal line at y equal 2 and get closer to the vertical line at x equal 3. Plotting the points for negative 4, be about right there, and negative 5, we get something kind of like that. So there's a lot of work involved in sketching the graph of a rational function. If you'll go step by step, it will be a lot easier for you.